Today is the second day of 11.2 where we are looking at the area of trapezoids, rhombuses, and kites. But today they are not quite as nice as they were yesterday, giving us all the information that we need, or maybe finding one piece of information. Now we're going to have to find a lot of different pieces of information in order to find the area of the shaded region of these figures that they give us. So all of the different tools that we have learned so far are going to come back, and we're going to have to remember and use those tools to help us find missing side links so we can find these different areas. Now, we're going to look at this first one here. This first one, it says to find the area of the shaded region. This is a kite. So I'm going to write down, all right, how do you find the area of a kite? The area of a kite is equal to my diagonal 1 times my diagonal 2, and I'm going to take that whole thing and divide by 2. So in order for me to know that, or to figure that out, I need the area, the length of my red diagonal there. So I'm going to mark that below here. I need to know what that distance is, and I also need to know what my length is of that diagonal right there, which I'm going to label or draw on the outside here as well, my blue one. Now, as I look at my picture, I can see, okay, they did not give me everything that I needed. If they were close, I know this distance right here of my red diagonal is 16, but I don't know what this is. And I don't know what any of that is right there with my blue diagonal. Now, the nice thing with a kite, here's where your properties are going to come back, is that with my kite, I know that this side length right here has to be congruent to that side length. So if I can somehow figure out what that side length is, then I can go ahead and figure out what that diagonal is. Now, as I look, and I'm kind of stuck. So again, whenever you get stuck, look for your right triangle somewhere. Now with a kite, one of those other properties again was that this is perpendicular right here, or it does make that right angle. So as I look at my kite here, I can see, all right, right here, I have a right triangle. And I can see, I know my hypotenuse is 18, and I know that one of my legs is 16. So I can then figure out what this side length is. Now, in all of these problems, you're going to want to look for, can I use my Pythagorean theorem, so a squared plus b squared equals c squared, or can I use my SOHCAHTOA? You're going to have to figure out which one you need to use in order to find those other side lengths. So I'm going to go ahead and call this diagonal, or that part, x, and I'm going to go ahead and redraw my triangle on the outside over here. So I just have a little bit bigger. So I know that this is 18, this is 16, and that is my x. So I'm going to use my a squared plus b squared equals c squared to figure out what that distance is. So again, doesn't matter which one is your a and which one is your b. So I've got 16 squared plus x squared equals 18 squared. So let's see, 16 squared, I get 256 plus x squared equals 18 squared, which is 324. So we subtract 256 over, so I've got x squared is equal to 68. You take the square root of both sides, and I take just the positive value, so x should equal 8.25. So if that's the distance right here, 8.25, and this is also 8.25, I take 8.25 times 2 to get my total diagonal distance of my blue diagonal. So 8.25 times 2 is 16.5. So I found my diagonal there, my blue diagonal. So that's awesome, that's great. Now, what I need to do is I need to figure out, okay, what is in my red diagonal? I already know that this is 16. Can I figure out what that one is right there? Well, since I already found that this side length here was 8.25, again, I see I have a right triangle right here. If this is 11, that means this down here is also 11. So I'm going to go ahead and write that in. And I'll go ahead and draw my triangle again, so that way I can kind of see what I have here. So I know that this is 11. We found x to be 8.25. That's my right triangle. So I'm going to call this, that red distance here, I'm going to call that y. That's what I'm trying to find. So I see I have two side lengths. If I have two side lengths of my right triangle, that means I'm going to use my Pythagorean theorem, my a squared plus b squared equals c squared. So we write this out. Again, doesn't matter which one's your a and which one is your b. I've got 8.25. That quantity squared plus my y squared should equal 11 squared. Okay, 8.25 squared. Well, if we look back at my problem over here, when we took the square root, I got 68. So 8.25 times 8.25 should be 68. So I'm going to go ahead and go back and use that value. So that way I know it's exactly right. And 11 times 11 is 121. I know that one. So we subtract 68 on both sides. So y squared should equal 53. You take the square root of both sides. So y is equal to 7.28. I'm going to round to the nearest two decimal places here. Okay, so I know that is 7.28. So to find my red distance, if I know one side is 16 and the other is 17.28, you add those two together. So my red diagonal, when you add them, it should be 23.28. 23.28. Now I have my two diagonals, so now I can actually find my area here. Okay, so my area is equal to my diagonal 1. So I've got 16.5 times the area of my second diagonal, my red one, which is 23.28. Take that whole thing, divide by 2. So we type this into our calculator, and I got approximately 192.06, and they didn't give us anything, so this is units squared. Okay, so that's one problem here. Now we're going to go ahead and look at problem B. Now this one, it kind of looks like a trapezoid, and it is a trapezoid actually. And I know it's a trapezoid because I have one set of parallel lines. Now, typically our trapezoids look a little bit different than this, but in this case this is. So to find the area of a trapezoid, again, if you need to, go ahead and get out those pink sheets, look at that area again. The area of a trapezoid is equal to, I have my height times my base 1 plus my base 2, and you take that whole thing, divide by 2. Again, you'll need to have that memorized. So when I look at my picture, I can see, all right, I have one base is 14 and my other base is 37. I just need to find my height. My height here or here, actually, it should be the same thing, but they don't give me that. So what I'm going to do is, I'm a little bit stuck here. So whenever you're stuck, look for a triangle or look and see if you can make a triangle somewhere. So what I see is that I can draw a line that comes down and is perpendicular. That's my height, right? It always should be perpendicular. And now I see, oh, look, I made a right triangle right there. And I know that that is 42 degrees. Now it says this whole thing is 37. And if this right here is 14, that means this down here is 14. So I'm going to kind of rewrite this. Okay, my red, I know this is 14. Take 37 minus 14. So this side length here should be 23. So when I look at my right triangle, I see, okay, I am trying to find this. I know this is 23, and I know my angle here is 42. If I know one angle and one side length, that's when I'm going to use my SOHCAHTOA to figure out what is my height. So if I'm using SOHCAHTOA, I look, okay, this is the angle that I'm looking at. It's been a little bit since we've done this. This is my angle. I look and see this is opposite of that angle, and this is adjacent. So I'm going to write my SOHCAHTOA up top so I can know which one am I going to use. Okay, I see I have an opposite and adjacent. So if I have an opposite and adjacent, I'm going to use my tangent. Okay, so to find my height, I take the tangent of my angle measure, which is 42, is equal to, it tells us what order, my opposite, which is my h, over my adjacent, which is 23. Now I'm trying to solve for h. Always get rid of that bottom part of your fraction first. Multiply both sides by 23. Those cancel out. So I have now h is all by itself. So we type in 23 times the tangent of 42. 23 times the tangent of 42. You can double check me on this. I got 20.71. So that's the height. All right, awesome. I found my height. Now I can go in and I can actually use this area formula to figure out what my area is. So my area is equal to my height, which we said is 20.71, times I add my two bases. Okay, so one of my bases is 14, and my other base, again, is the whole thing is 37. Take that whole thing, divide by 2. Okay, so make sure you do your order of operations correctly. First, 14 plus 37 gets me 51. So I have 20.71 times 51, all divided by 2, which equals, I got 528.105, and we're talking about units squared. Okay. All right, so that is letter B. Let's move on now to letter C. This one here. Okay, I can see I have, let's see, this side length and this side length, those are congruent, and those are congruent, which are adjacent to each other. So that means this is a kite. So again, I'm going to look at those diagonals. So I've got my red diagonal right there. I need to figure out what that is. And I have my blue diagonal right here. So I need to figure out what that is as well. Okay, now once again, they were not super nice and they did not give us everything. Just as we did in our first one, I'm going to go ahead and find this right here. I know it comes down and is perpendicular because I have a kite. I'm going to figure out what my x is, because this x right here is also equal to this, so I can figure out my whole diagonal length. I see I have two sides of my right triangle, so I'm going to use my a squared plus b squared equals c squared to figure out what my x is. So let's see. I have x squared plus 35 squared is equal to 37 squared. So let's see. 35 squared is 1225, and 37 squared 1369. You subtract 1225 over, so I've got x squared is equal to 144. Take the square root of that, and this actually came out nice. X is equal to 12. So if that's the case, I know that x is 12 and x is 12, so 12 times 2 is 24, so that is the length there of my red diagonal. Okay, I know that. Let's see, how else can I figure out, let's see, I'm trying to find this blue length here, I know it told me that one was 35. So I just need to find that blue one. I'm going to go ahead and redraw my triangle that I have up in that corner. It's a little bit bigger so I can kind of see what I got. It tells me that this angle inside of here is 30 degrees. I know that's right. And we just found that this was 12. So let's see. I'm trying to find this right here. Actually, I should call that Y. I'm going to call that Y. Okay, so that's Y. So I have one angle and one side length, so I need to use my SOHCAHTOA. So I look and see, okay, this is opposite and this is adjacent. So once again, I'm going to go ahead and use my tangent. I have the tangent of my angle 30 is equal to my opposite, which is 12. Ugh, sorry, I don't know why it keeps doing that. Over my adjacent, which is Y. Multiply both sides by Y. So I've got Y times the tangent of 30 is equal to 12. Y is not quite by itself. Divide both sides by the tangent of 30. So Y is equal to 12 divided by the tangent of 30, which I got 20.78. So my whole blue diagonal should be my 35 plus that 20.78, which I end up getting 55.78. Okay, I have my diagonals. Nice job. Now let's go ahead and find our area. So the area is my two diagonals, diagonal 1 times diagonal 2, divide by 2. So my area is equal to, let's see, my first diagonal, we'll take our blue one, 55.78 times 24. Take that whole thing, divide by 2. So the area, again, double check me on my math here. I got 669.36, and this is units squared. Okay, we are going to go ahead and skip this part D just for time purposes. I'll kind of just briefly talk about it. In order to find the total area, you would have to find the area of this square, find the area of this kite right here, and add those two together. So I do have that up on Blackboard that you can go ahead and check. Okay. We are going to go ahead and do our very last example, which says example 2. Okay, example 2 says sketch the figure, then determine its perimeter and area. The figure is a rhombus. All right, rhombus. What do I know about a rhombus? Think back at those different properties. Okay, a rhombus. All of my sides should be congruent. And if we're trying to find the area, which it did ask us to find that, I'm going to need to know what my diagonals are. So I've got my rhombus. All of my side lengths should be congruent. Okay, it says its side length is 5. So all of these here are 5. 5, 5, 5. The length of one of its diagonals is 8. Okay, sweet. It doesn't specify which one, so you can just go ahead and pick one. So I'll go ahead and pick this one. This one here, that diagonal is 8. Now, if that's the case with our rhombus, I know that my diagonals are cut in half. So that means this should be 4, and this here also should be 4. With a rhombus, we also have our right angle right in here, which means I can see, oh, look at that. I have my right angle. I've got a triangle. So I can actually figure out then what my other side length is. So let's see, our blue diagonal is the other one that we need to find in order to find its area. Okay, so that is my X right here. So I have two side lengths, so you do a squared plus b squared equals c squared. So x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. Subtract 16 on both sides, so x squared is equal to 9. Hey, would you look at that? X is equal to positive 3. Now, if you noticed that this is a 3, 4, 5 triangles, one of those special triangles, that's also a shortcut to know that your x is 3. So if that's 3, that means my whole diagonal is 3 times 2, which should be 6. Okay. Now they wanted us to find the perimeter and the area. All right, so perimeter, you take everything on the outside and add it together. 5 times 4, I've got 4 of them. Ugh, come on. 5, there we go. 5 times 4, which is 20. And did it tell us any units? Nope. So my perimeter is 5 times 4, which is just 20 units. The area, you take your two diagonals. 6 times 8, divide that by 2. 6 times 8 is 48. 48 divided by 2 is 24. And this is units squared.